I'm going to demonstrate how to solve for a specified variable, particularly for equations where we have either radicals or second-degree terms, which would make those equations quadratic equations. In this case, we have an equation with a radical, and we're asked to solve for L. And in order to get to that L, we would need to remove the radical. So we're going to make use of the fact that squaring and taking the square root are reverse processes, and we will then simplify this equation by squaring both sides. So on the left we get t squared is equal to, and when I square the right, I have to square every piece or every factor in this expression. So 2 squared gives me 4, and I also have to square the pi, so this is pi squared. And then squaring this radical will lift off the radical symbol, so now I've got the fraction just L divided by G. Next, when I want to solve for L, to isolate that, I've got a G in the denominator, so I'm going to multiply both left and right times G, and that will allow me then to get rid of this fraction here. Pulling the terms together, I have gt squared is equal to 4 pi squared L. And finally, the last step to isolating the L is just to divide by the multiplier, in this case 4 pi squared in front of the L on the right, and also by the same on the left. And so we end up with then that L is equal to gt squared divided by 4 pi squared. And this is the solution for L. So we can tidy this up by putting L isolated on the left is equal to gt squared divided by 4 pi squared. Let's move on to another example. This time we have a formula, the displacement formula, that involves not a square root, but a squared. So we have S is equal to V0t plus 1/2 at squared. And in order to isolate the t, this is a second degree or quadratic equation, and so we are going to isolate this by using the quadratic formula. One simple thing that I'm going to do is get rid of the fraction, so I'll multiply everything on the left and right by 2, and that gives me that 2s is equal to 2 times v0t plus 1 times at squared. Next, what I'd like to do is to rearrange the terms in descending order with t as the variable. So I'm going to have t squared terms first, and then t to the first power terms, and then the constants or the non-t terms last. So when I subtract 2s off the left-hand side, it becomes minus 2s on the right. And now we have a quadratic equation. It's not necessarily what you're used to seeing, where you usually expect to have numbers in front of each of the t terms, but we can still consider these values to be a, b, and c. So the coefficient or the expression in front of the t squared is just a, so we can say that a is equal to a. That's convenient. But for our second term, for the coefficient of the t to the first power term, we have 2 times v0. And for our third term, or the non-t term, which is like a constant, we have minus 2s. So that will be our value of c. And now we can take these expressions and plug them into the quadratic formula. So t is the second degree variable that we're trying to solve for, is equal to negative b, which is negative 2 times v0, plus or minus square root of that b squared, 4v0 squared, minus 4 times a times c, which is negative 2s. The first term has a 4, and the second term, we take minus negative, becomes plus, but this term also has a 4, which can be factored out. We take the square root of that, and it becomes 2. And so we have 2 times v0, and then 2 also times the second term, the radical, which can be canceled with the 2 in the denominator. And our final answer is negative v0 plus or minus square root of v0 squared plus 2as divided by a. And that again is the solution for t.